Hello everyone. F-test is crucial for engineers as it helps compare variances between datasets, determining if models or processes differ significantly. It supports quality control, optimization, and decision making by validating hypotheses in experimental design. In this video, I will be explaining the steps for conducting a F-test and its significance with the help of solved examples. Let us first see what is F-test. The F-test is a statistical test used to compare the variances of two or more groups to determine if they are significantly different or not. It is commonly employed in analysis of variance, that is ANOVA, regression analysis, and for comparing models. Variance tells us how much the data in each group varies or is spread out from the average. In simple terms, we can say that the F-test helps answer questions like, do two machines produce parts with similar consistency? Do two groups of workers perform tasks with same level of variation? Are the errors from two different models similar? It works by comparing the ratio of the variances between the groups. If the ratio is much larger than expected, it suggests the variances are not equal, meaning there might be a significant difference in consistency or spread between the groups. The relation we use to perform F-test, which compares the variances of two groups, is F equal to Sx square upon Sy square, where Sx square we know is the variance of the first sample or sample X, and Sy square is the variance of the second sample or sample Y. Here it is to be noted that the group with the larger variance is always taken as sample X, while the group with the smaller variance is taken as sample Y, so that the ratio Sx square upon Sy square is always greater than 1. Now we will see what are the steps used to perform F-test. So, as we have seen in t-test, the first step is formulate hypothesis. So we formulate null hypothesis and alternate hypothesis. In null hypothesis, we can say that variances are equal. In alternate hypothesis, we can say variances are not equal. Then we calculate F statistics, and the relation for the same is F equal to Sx square upon Sy square, or the larger sample variance upon smaller sample variance. Let us see step 3 for the F-test. And in step 3, we determine the degree of freedom for both the samples. For the sample in numerator, we say the degree of freedom as df1. And for the sample 2, or the sample which is in denominator, we take degree of freedom as df2. And the degree of freedom is always n minus 1. Sample size minus 1. Then in step 4, we use the F distribution table to find the test statistic value or F value at a particular significance level. We generally take it 0.05, or if it is given in the problem, we take that value. Then in step 5, we compare the calculated value and the test static value. That is, we compare the calculated F value with the critical F value. If the calculated F value is greater than critical F value, null hypothesis is rejected. If the calculated value is smaller than the critical F value, null hypothesis is accepted, or we fail to reject the null hypothesis. If the calculated F value is larger than the critical value from the F distribution table, we reject the null hypothesis that the variances are equal. For example, if in a production engineering context, you might want to test if two different machines produce parts with the same variance in dimensions, that is quality consistency, the F test would help determine if the variability between the two machines is statistically different or not. Here is the F table for alpha 0.10. Similarly, we can have F table for alpha 0.05 for other values of alpha also. Here it is df1 and df2. df1 is in row and df2 is in column. Since there are two samples, so we calculate degrees of freedom for both the samples, and accordingly we see the critical F value or the test statistic from this table. For example, if a sample has degree of freedom 9 while the other sample has degree of freedom 10, so we can see the corresponding F value as 2.35 for alpha equal to 0.10. So let us see how to perform F test with the help of a solved example. We have already seen the steps which will be used for performing F test. Here is an example. Two machines, machine A and machine B, are producing a metal part. Check if the variability or variance in the dimension of the parts produced by these machines is the same or significantly different. The data from two machines is given and the dimensions in mm are given here. We have to check whether there is a significant difference in variability in variance or not. So to perform F test at 5% level of significance, if the variance of two machines are different or not, we will follow steps. Step 1, we will calculate the variance for both the machines A and B, and variance will be Sx square or Sy square, where Sx square will be summation x minus x bar whole square upon n minus 1, n is sample size, x bar is mean value of the sample, of the first sample, and x is the each value of the sample. To find the mean value, that is x bar or xa bar of the sample data for machine A, we have added all the values and divided it by 7. It comes as 12.23. To calculate variance, we can apply the relation summation x minus x bar whole square upon n minus 1. So here we can calculate the value for each difference. First value is 12.1 and the average is 12.23. So first value will be 12.1 minus 12.23 whole square, that is 0.0169. Then we can calculate another value 12.3 minus 12.23 whole square, and so on. We can calculate third value as 12.5 minus 12.23 whole square. Fourth value 12.0 minus 12.23 whole square. If we add all these values, we get summation xa minus x bar whole square, and it comes to be 0.091. So this way we have calculated variance for sample data of machine A, that is SA square. It will be summation x minus x bar whole square upon n minus 1. So that is 0.091 upon 7 minus 1, and it will be 0.0152. So this way we have calculated the variance for the sample data of machine A. Similarly, we can calculate variance for the sample data of machine B. First, we will calculate average value or mean value by adding all the values. Since sample size is 8, we divide it by 8, we get mean value as 12.01 mm. To calculate summation xb minus xb bar whole square, that is first value is 11.9, mean value is 12.01. So we will calculate 11.9 minus 12.01 whole square. Then 12.0 minus 12.01 whole square. Then 12.2 minus 12.01 whole square. Then 11.8 minus 12.01 whole square. If we add all the values, we get summation xb minus xb bar whole square. It comes to be 0.052. We can also calculate the value of summation xb minus xb bar whole square by column method, in which we will put all the sample values in one column, then we will calculate mean, then we will create a column of xb minus xb bar, then we will create a column of xb minus xb bar whole square, and by summing all the values. Variance value can be calculated by summation xb minus xb bar whole square upon n minus 1. So that is 0.052 upon 8 minus 1, 0.0074. So this was the first step in which we have calculated the variance for both the samples, sx square, sy square, or sa square, sb square. Now in step 2, we will formulate a hypothesis. Here we can take the null hypothesis as the variance of the machine A and machine B are equal, while alternate hypothesis will be the variances of machine A and machine B are not equal. Then in step 3, we will calculate F statistic by applying the relation SA square upon SB square, or SX square upon SY square, which we have already calculated, 0.0152 upon 0.0074. It will be 2.05. In the next step, we will determine the degree of freedom for both the samples. For machine A sample, the degree of freedom will be n minus 1, that is 7 minus 1, 6. For machine B samples, degree of freedom will be n minus 1, that is 8 minus 1, 7. Then with the help of degrees of freedom and alpha value, we will calculate the critical value or find the critical value from the table. At 5% level of significance, alpha will be 0.05. And using F distribution table, as I have discussed earlier, for degree of freedom 6 and degree of freedom 7 in denominator, the critical F value will be 4.21. Now in step 6, we will compare the F statistic and critical value. So as calculated, F statistic is 2.05, critical F value is 4.21, which is seen from the table. We can now make decision in step 7, and since the calculated F statistic 2.05 is less than the critical F value 4.21, we fail to reject the null hypothesis. That is, null hypothesis cannot be rejected. This means there is no significance difference in the variance of the parts produced by the two machines. That is, we accept the null hypothesis. From this test, we can conclude that the variances in the part dimensions produced by machine A and machine B are statistically similar, meaning both the machines produce parts with similar consistency in their dimensions. Please like, share, and subscribe to our channel to keep us motivated in creating more such contents. Thank you.